Hello! Today we're going to be going over everything about gold that you need to know for the Indiana Academic Super Bowl. Now, in this presentation, I'm going to be going over everything, but if you're just here for review, I'm going to have a slide at the end that's just the key takeaways of what you need to know about gold. So, if you're just here for review, I recommend just looking at that slide. Now, this is everything that the Indiana academic team wants you to know, which involves the chemical properties of gold, the physical properties of gold, which provinces produce the most gold, how gold is mined and extracted, the uses of gold, the percentage composition of gold compounds, and why we care about gold compared to other industrial metals. This is everything that they want you to know, and this is everything that we're going to go through in this presentation. Now, to start us off with the chemical properties of gold, we have a face-centered cubic crystal structure for gold. Now, this means that for each unit cell of gold, there will be 4 atoms of gold. Now, why we care about gold compared to other metals is that it's extremely unreactive. It will only react with certain halogens, which are chlorine, bromine, and iodine. And it also forms a complex with cyanide. And this is the only 4 reactions that can occur with gold. And this unreactive nature, it makes gold considered a noble metal, which just means that it's resistant to rusting. Now, if you recall what rusting means, it essentially just means reacting with oxygen in the air to produce something else. And gold does not do that. Now, the most common ion for gold is 3+, but it can also be 1+. And the most common isotope is gold 197, which is 100% of naturally occurring gold. Now, that's all the chemical properties you'll need to know. But there's also gold's electron configuration. And we need to know gold's electron configuration for the competitions. And gold's electron configuration is a little bit of an exception. When you write the electron configuration for gold normally, you end up with xenon 6s2, 4f14, 5d9. This, however, is unstable. There's a rule where orbitals are much more stable when they're half-filled or completely filled, which makes the 5d9 orbital unstable in this gold compound, in this gold atom. Now, gold makes up for this by moving one of its 2 6s electrons to completely fill the 5d orbital. So, it creates the electron configuration xenon 6s1, 4f14, 5d10. You just need to remember that gold moved one of its 6s electrons into the 5d orbital. And as you can see here, the 6s orbital is half filled, so it's stable, and the 5d orbital is completely filled. So they're both stable, and the gold atom is stable. Now, going over the physical properties of gold, another reason why we care about gold is that it's a highly efficient conductor of electricity and heat. And we'll talk more about that later. Now, the density of gold is about 19 grams per cubic centimeter, and it can only be dissolved by something called aqua regia, which is a mixture of nitric acid and hydrochloric acid. This forms something called tetrachloroauric acid, which you might need to know for this competition. But the main takeaway from this is that gold can only be dissolved by a mixture of nitric acid and hydrochloric acid. Now, 1 atom of gold weighs about 197 AMUs, because as you recall, the most common gold isotope is gold 197. Since a unit cell of gold contains 4 atoms with its face-centered cubic structure, 1 unit cell of gold weighs 4 times 197, 788 AMUs. Gold is the most malleable and ductile metal known, and real quick, I want to go over the difference between these two because you'll need to know that for the competitions. Now, malleability is the capability of a metal to deform permanently in response to external stress, which essentially means Something that's malleable can be hammered or squished without breaking. So you can press it down into thin sheets and it won't break. Now, ductility is the capability of a metal to deform permanently in response to tensile stress, which essentially just means internal stress in the object itself, which basically just means that something that's ductile can be stretched, bent, or spread without breaking as easily as other metals. And gold is the most malleable and ductile metal known, which means it can be spread into extremely thin sheets and stretched into extremely thin wires. Now, the context of gold in relation to Canada is fifth in the world in gold production and produces about 5% of the world's total gold. Ontario produces the most gold in Canada. Ontario is the province that's just north of Indiana and Michigan. Ontario produces the most gold in Canada, with Quebec in second, and Quebec is just to the right of Ontario, as you can see in the picture. Ontario and Quebec account for about 75% of the total gold production in Canada, and for this reason, you don't really need to care about the other provinces' gold production, because these two provinces make up the bulk of gold production, and that's all you really need to remember. Canada produces about 175 metric tons per year of gold, and the value of the gold exports is about $22 billion. Now, how does Canada mine gold? Well, Canada predominantly uses open pit mining to mine gold and diamond ore. This is the most common globally, and it's used when minerals are found close to the surface of the earth because it's easier and cheaper when you're looking for mass production of a certain mineral. Now, going over what open pit mining looks like structurally, if you have the surface here, which you see on the left, open pit mining uses a sort of stepladder approach, and the incline of that step is called the batter, and the step itself is called a bench. And the reason why open pit mining uses this stepladder approach is that if rocks were to slide, say from the surface to the bottom of the mine, it would actually hit the bench instead of the bottom of the mine, which is where workers would be working. So it's just to prevent rock slides and avalanches from occurring because the bench would stop it. Now, this is a picture of what a real life open pit mine looks like, and you can see the sort of stepladder approach that they're going for here. And again, this is just to stop rock slides and avalanches. And the thing I have circled here is just a transport truck that they use for the gold. And this is just, the reason I circled that is just so you can see how big these open pit mines tend to get. And yeah. Now, once you find the gold using this open pit mining method, the question is, how do you extract it? So, gold is mainly extracted using a leaching process named cyanidation. Now, leaching means extracting something from an ore by dissolving it. And you use leaching whenever you can dissolve something from an ore, and you won't dissolve anything else. You won't dissolve the stone that's keeping the mineral in, or there might be other metals in there. So that's when you can only use leaching when you're only dissolving the thing that you want. Now, cyanidation is a specific type of leaching, and it's when a cyanide compound reacts with gold to create a gold complex compound. And this gold complex compound is soluble in water. So what they do is they just wash the gold ore with the cyanide compound dissolved in water to leach the gold out of the ore and then transport it elsewhere. Now, once you have this gold complex compound, the question is, how do you get it out of the compound? Well, the most widely used process to extract gold from a gold complex is called carbon in pulp. Now, oversimplifying it, the process is where Activated carbon, which is also activated charcoal, it acts like a sponge, which pulls the gold from the complex. The carbon can then be filtered out, which leaves you with pure gold. This is a simplification of the process, but that's all you would need to know. Now, how is gold used? Well, most gold, about half of all gold in the world, is used for jewelry, and the main reason is that it looks nice. It doesn't rust or corrode like other metals, and it always keeps that polished look. Now, 30% of gold is used for investment purposes. Some economists believe that gold is immune to inflation, like gold value would go up in response to inflation. That's just what they believe. 15% of gold is bought by banks to use as reserves. And this is just in case gold, just in case we go into a depression, the banks still have gold to use as money in case they need some. Now, 7.5% of gold is used for technology. And the reason for this is gold is a very efficient conductor. It can be drawn into extremely thin wires, and it efficiently conducts electricity. Now, one thing I want to go over real quick is the percent composition of gold. And there are two variations of carat, and you need to know the difference. Carat, with a K, refers to the purity of gold in an object. 24 karat gold refers to pure gold. Now, so for example, if you have a ring that is 12 karat gold, then you take the carat number divided by 24, which is pure gold. So 12 divided by 24 equals 50% of the ring by mass is pure gold. Similarly, a ring that is 18 karat gold would be 18 divided by 24 equals 75% pure gold by mass. Now, carat with a C, you have to watch out for, because carat with a C is not related to gold in any way. Carat with a C is a unit of mass, which equals 0.2 grams. Carat is normally used to measure the weight of a diamond. It doesn't have anything to do with gold. Sometimes carat with a C is used interchangeably with carat with a K. However, in this competition, that won't happen. So just remember to know the difference. If it's carat with a K, they're most likely talking about gold. If it's carat with a C, they're most likely talking about diamonds. Now, you might ask why gold is used compared to other metals. Now, industrially speaking, gold is only used to conduct heat and electricity. The other uses tend to be jewelry and investment. Now, while copper and silver are the best conductors on the market that conduct electricity the best, they are vulnerable to rusting and corroding. They can react with oxygen and create something else that isn't as good as conducting as what it once was. Gold is immune to this. It doesn't rust or corrode. Now, since gold is the most ductile material, it can be drawn into extremely thin wires. And this is really helpful in systems where they need to save space. And as the most malleable material, gold can be pressed into extremely thin sheets, and this makes something called gold leaf, which is used for a lot of things, but gold leaf is 1,000 times thinner than paper. Now, if you think about how thin paper is, gold leaf is 1,000 times thinner than that, which is kind of crazy. Now, the key takeaways from this presentation is that gold is valued because of its unreactivity, malleability, and ductility. That's the main reason we care about it. Canada is 5th in the world in gold production, and Canada produces about 5% of the global gold. In Canada, Ontario produces the most gold, with Quebec following second, and those two provinces contribute 75% to Canada's gold production in total. Canada itself mainly utilizes open pit mining to mine gold, cyanidation or leaching to extract it from the ore, and carbon and pulp to isolate it. Gold is mainly used for jewelry because of its unreactivity. It always keeps that nice look to it. But it's also used for investment purposes and technology. Carat with a K refers to gold purity, while carat with a C is a measurement of 0.2 grams. And 24 karat gold is pure gold. Now, this is everything that you need to know about gold. And thank you for listening.